Hello everyone. I have here a few examples of problems working with position, velocity, and acceleration. We'll go through each one part by part. So the first thing before we even read this problem is to just remember that position, which this problem is calling S of t, but you'll see it written several ways. They might call it h of t in certain problems because that represents height, or they might even call it x of t, which can be kind of confusing, but those are the different labels that it's typically given. Now, velocity is the derivative of position. So velocity is s prime of t. I'll just write it that way. Or you can relabel it its own letter, but you do need to know that it's the derivative of position. And then acceleration is the second derivative, so that would be s double prime of t, or in other words, v prime. So if you have velocity, you can just take the derivative again, and that will give you acceleration. And then you can also give it its own name of a of t. So that's how position, velocity, and acceleration are all connected to each other. Now, part A of this problem is asking for displacement. Displacement, and I'm going to write these notes in common sense terms, not with mathematical formulas that you would find in a math book. So displacement is going to be the ending position minus the starting position. That is how you find displacement. And let's think of it, I'm going to write over here displacement on an interval, and let's just call that interval A, B. And so in a more formulaic way, end position minus starting position would be plugging in S of the second number, B, minus S of the first number in the interval, which is A. Now, in this problem, it says, find the displacement during the first 5 seconds. Well, the first 5 seconds means it's the interval from 0 seconds through 5 seconds. So 5 is the ending time, and 0 is the beginning time. So the ending position would be plugging 5 in to the s of t. So what we're basically going to do in this problem is do s of 5 minus s of 0. And the s equation was given up here in the original wording of the problem. So that's going to be doing 5 squared minus 3 times 5 plus 2. That's that. Minus 0 squared minus 3 times 0 plus 2. So this will give us 25 minus 15 plus 2 minus 2, because the rest of that's 0. So let's see, 10 plus 2 is 12. So 12 minus 2 gives us 10. Displacement is how far someone is from their original position, so that would be measured in meters. So it's 10 meters for the displacement answer. But the one thing you can remember for any problem, not just this particular problem, is that it's end position minus starting position. So on a certain interval, you plug those two numbers into the position equation that they give you, s of b minus s of a. Okay, now we'll get a new page here to do part B. So part B is asking us find the average velocity during the first 5 seconds. All right, so average velocity, let's write out what this is. Average velocity average velocity is just like finding slope. You can think of it, some teachers call it AROC, average rate of change. So you can think of it in a lot of different ways, but it is S of B minus S of A over B minus A. Okay, basically that is like having the old slope formula, y2 minus y1 over x2 minus x1. It's the same exact thing. And the interval on this problem again is 0 to 5 because they said during the first 5 seconds. And actually we just found S of B minus S of A in the first problem, but let's just redo that work. So it was S of 5 minus S of 0 over 5 minus 0. Now I did do the work for the numerator on the other page, so that was 10 we got over 5, so this ends up being 2 altogether. And that's a velocity measurement, so we would say meters per second. So that would be that answer. Now we can fit this on here. We will do the next one, which is find the instantaneous velocity when t equals 4. Instantaneous velocity is just finding the derivative. Instantaneous velocity is you're going to find v of t by taking derivative of position. So we're going to do s prime of t and plug in 4. Okay, so the original equation is written above, so s prime of t, the derivative, would be 2t minus 3. And then we're going to plug in 4, because that's what they asked us for, the instantaneous velocity when t is 4. So that will equal 2 times 4 minus 3, which is 8 minus 3, so that's 5. And again, this is a measurement of velocity, so it's 5 meters per second. And that's instantaneous velocity. Now we'll do part D, which is asking us to find the acceleration of the particle when t is 4. So acceleration, remember we said on the front page that acceleration is the second derivative, so it's s double prime of t, and then we'll plug in 4. Alright, so we had the first derivative written on our other page, which I'll just remind you, it was 2t minus 3. So now s double prime will equal just a constant of 2. And there is no place to plug in 4, but that just means that s double prime of 4 still equals 2. And then let's just rename this. It's this s double prime is the same as acceleration. So let's say a of t equals 2, and that's the answer. And that would be meters per second squared, because that's how you label acceleration. And I want to show you an extra little problem here. Let's call this D2. What if they said find average acceleration during the first 4 seconds? Well, whenever we did one with average velocity, but I just wanted to point out, whenever they ask for average anything, you plug in the interval, which was, it would be 0 to 4. You plug in the numbers from the interval into the previous equation. So for average acceleration, you would do velocity of 4 minus velocity of 0 over 4 minus 0. You always do average quantities that way, whatever they're asking for. And the reason is because the average acceleration is the slope of the velocity graph. So we're just finding the slope along the velocity graph between 0 and 4. So remember, the velocity, I'll just put a little star here. We had written it down before. V of t was 2t minus 3. And so to get our numerator, we would do v of 4, which would be doing 2 times 4 minus 3, minus 2 times 0 minus 3. Let's put a double parenthesis here. All over 4 minus 0. So this would give us 8 minus 3 is 5, minus negative 3 over 4. That's going to be 8 over 4. So that would be 2 meters per second squared. It's the same answer in this problem as the just regular acceleration in part D, which was the instantaneous acceleration, but it won't always necessarily be the same answer. And that brings up one more thing I wanted to be sure to say. If they don't say a word before acceleration or before velocity, they are talking about instantaneous. And so that is when you just find the derivative and plug in the number. Whenever they say average is when you're going to be subtracting in the numerator and the denominator. Now part E is asking, at what values of t does the particle change direction? So let's talk about changing direction. Changing direction has a couple parts to it. First, you want to find where the particle is at rest. And you do this by setting v of t, the velocity, equal to 0. Because if something's at rest, it's not moving. So the velocity, which we found on a previous part, was 2t minus 3. And we set that equal to 0 and solve. T will end up equaling 3/2. And that's step 1. So we know that for sure the particle is at rest at 3/2 seconds. Now part 2 of finding out where it's changing direction is to plot your at rest values on a number line. Like this. Now actually time cannot go below 0, so we'll call the beginning of the number line 0, and it'll only go on in the positive direction, and then I'll stick 3/2 on here. And then what we're going to do is test a number from each region back into v of t to find if your answers are positive or negative. All right, so for example, in this little portion, I could plug in 1. That would be pretty simple. And so I'm plugging it back into 2t minus 3. Let's write that this is v, that's velocity, is 2t minus 3. So I would be plugging in 2 times 1 minus 3, and that equals -1, which is negative. So in this region, I get a negative. Now, an easy number in this region would be 2. So let's plug in 2 times 2 minus 3, which is 1. And so therefore that came out positive. So in that part of the number line, the velocity is positive. So since the velocity changed from a negative to a positive, that means that right at 3/2, the particle did change direction. If it had remained negative, negative, the particle would have just come to a rest, but then kept going in the same direction. So that's why we do this number line test. So it changes direction at t equals 3/2 seconds. And that's our answer for part E. And the last part of this question is asking, where is the particle when S is a minimum? So when the position is a minimum, they want to know where the particle is located. Well, here's our S of t. It was the equation t squared minus 3t plus 2. Now, anytime they start asking you to find a min or a max of an equation, we've done a lot of the work already, but I'm going to just outline the steps here as if you were starting from scratch. Min or max, you find the derivative of that function, you set it equal to 0, and you solve for the t, or the variable. You plot your number line, and you test for positives and negatives, just like we did a second ago. And then if it's going, so on a number line, if it's going from positive to negative, positive tells us that it was an equation that had a positive slope, and negative tells us it was an equation with a negative slope. And so positive switching to negative would create a max. And then just the opposite, if you have a number plotted and when you test you get a negative followed by a positive, that means that the original equation was going down and then up, which that would create a minimum. So, to find the minimum of this S equation, we did the work on the other page. We had our number line. We had 3/2 plotted on it. And it went from negative to positive. We already did all that work in part E, so I'm just not repeating the work. So that means that the original position function had a negative slope followed by a positive slope. So it had kind of like that general shape. So that means that 3/2 was a minimum. Now that's the seconds. Part F is asking, where is the particle? Well, the where is answered by the position function, because position is where we are or where something is located. So what we're going to do is take the S of t equation and we're going to plug in S of 3/2. And that will tell us where the particle is located, right at 3/2 seconds. And we'll probably get a fraction, but that's fine. So if we do this out by hand, I'm going to get 9/4 minus 9/2 plus 2. And you can use a calculator if you need to, but this comes out to negative 1/4. And that's a position which would be measured by meters. And so the particle is at negative 1/4 meters compared to wherever it was before. So the answer is just negative 1/4 meters. That might seem funny that a position came out negative, but that is possible because we're talking about a particle moving on a line. So it's probably in relationship to the origin. And so that is it.